Let's now talk about testing. Testing is so vitally crucial, and unfortunately, so many times I've seen that really testing something gets squeezed to the very end of the project, and then something's not tested adequately before it has to be released. And then they figure, oh, we'll fix it in the mix, or we'll fix it and release updates or patches. And now you've got this big problem for the infrastructure and the deployment team because something isn't working properly. Or I've been in many situations like this. As we're going, we know we're not going to meet our release date if we try to make this work. So what do? Do we hide the elements from the interface so people just can't see it? Do we gray it out? What do we do with it? And so you got to have testing all the way along. It gives you confidence from the beginning. And when you have testing, it's not something you should save to the very last minute. You should have a test plan as you're planning and designing the whole project. And we're going to talk about different kinds of testing, where they can happen, where they can occur, and how they interact. So as an IS auditor, we've got a little checklist here. When we're looking at the testing process management, we want to see a test plan that is developed during the planning stage. You should not be saving testing till the last minute. We want to make sure there is the correct test strategy, and we'll talk about those strategies in a moment. We want to make sure that there is documentation and management of the test environment, because I have been in situations where code that is just in beta or is just being developed or being tested accidentally leaked into production. And I mean, it does happen. You want to make sure that the test tools are good, and make sure that there's a clear understanding of all the entry and exit criteria. So the entry, what has to happen and come in before we start, and what has to happen at the end. So first of all, the test plan, and this is actually when you do SDLC, software development lifecycle, or system development lifecycle types of development. Test plan early on, after we've gathered the requirements and we're starting to design this thing, our test plan is created right then and there during all the other planning as we start going into the design phase. And we need to have testing all the way along because we need the certainty that every bit of code has been tested, that the different parts of this application have been tested to work with each other, that the whole system works with other systems and within the environment, that it doesn't break anything that previously existed. But the test plan is a formal document that says exactly what we're going to test, how, when, why, what areas. There are two strategies for testing, and I have a personal preference, obviously. You can test from the bottom up, meaning that even as we write code, we're testing units of code, and that actually is a preferred method. You can also test from the top down. When we see that we're done, we'll test. Now, top-down can work when you actually have something that pre-exists and you now need to maybe update it, fix it, or change it. We'll do that. We'll top-down test, and then we'll see what's not working, and then we'll hunt it out. But if you're building something from scratch, you're going to want to test bottom-up, really. So different types of testing, different classifications of testing. So when you're, as an IS auditor, investigating, did they test? Starting with the developer writes the code, and they write some little thing, and they'll unit test that little thing. And the test is basically just a yes or no. True or false, did it do it or did it not do it? So like maybe the unit test could be as simple as, did this thing actually give us a particular output? I mean, we're writing a really simple mathematical function of multiplying this versus that, and does it come out with the correct output? Or it can be, it'll be a very simple thing. If you involve the client in, say, an agile process, and they see the unit testing every single day and every single time that you've written something, and they see that yes or no, yes, this little piece passed, yes or no, this little piece passed, it'll give them such a level of confidence in what you're doing. You want them to see the unit testing. So that's the beginning, just this little tiny bit of code. Does it give us a yes or a no? And then from there, when we've got sort of like whole blocks or modules, we want to test the integration of those. We want to see how well this part of the code interacts with that part of the code. So we'll do integration testing, because I might be working on this part, you might be working on that part, or this part already exists, or I'm writing to that web interface, or I'm writing to that database, or I'm writing to that modem. So we'll see how well it integrates. So that's integration testing. So we've got the unit testing, these little tiny bits, then integration testing, all the modules, the functionality within an application. Then you've got the system testing. And does this system actually work in the environment? Does it, so we wrote this application that's supposed to talk to a web front end, or supposed to talk to a database, or supposed to dial up a cellular modem and transmit information over to another location. So let's test it against the environment and the existing other systems. Once we're satisfied with that, we're ready to actually roll this out, and we want to make sure there's final acceptance testing. So are people actually using this thing? I mean, did we spend 6 months to have nobody want to use this? I have certainly seen situations where we did not involve the client well enough up front, and the acceptance testing was a complete reject, because the client, in this case it was a bunch of nurses, said, but that's not how we do our workflow. That interface where you've arranged certain things and we're going to enter data does not work for our workflow at all. Why didn't you involve us? And we had to take the whole thing back to the drawing board and basically rearrange it. I mean, we reused elements. So that was an example of we didn't involve our clients well enough, and when we finally got to acceptance testing, it was a bust. Ultimately, when we do have acceptance testing, it does do what they want it to do, what the customer needs it to do, to improve their workflow, their process, solve some kind of business problem. Then we roll the whole thing out. And we also have to periodically test to make sure that it doesn't break something and make sure it's still running, and we have to maintain performance metrics. So remember that the development team is going to have to be standing by to make sure that during the deployment, if there are any bugs or any kinds of quirks or tweaks, that they're there to take care of it. I mean, I've certainly had that where we rolled out a patch and nobody could log on. And the bug was a very odd one, but unfortunately we insisted on having a developer on site with us, so he was able to fix it after a couple of hours. He figured out what was going on, and he released another patch, and it worked okay. So anyway, we've got to make sure that there is final acceptance testing. There's another kind of testing called regression testing, and that is, I'm going to fix something or change something, and I'm going to run all the old tests to make sure that the thing I've changed now does not come up with failed old tests. So whatever I've changed does not break anything, and I find that out by running all the original tests to see if it passes all the original tests. So these are different types of tests, and you should include all of them, and as an IS auditor, make sure that all of these were done to have quality assurance and to make sure that the project stays on track and produces something that serves the business need. When you do testing, you can have automated testing tools as well as manual testing. Automated tools especially work when like your unit testing, and we'll just run something and we get a yes or no answer. Or we will stress test something. We're ready to test this whole system, and we're going to pound it very hard with a simulated heavy workload, deliberately trying to take it to its breaking point. So we can automate things that way. Or we can do manual tests. So like we had a situation one time where this minor release had to fix some reporting problems. Well, the only way to do that, really, we didn't have an automated test to test for the reporting. So we had people who work in the field who knew what they wanted to see in the report, just try all kinds of random reports to see if they got the data that they needed out of this software. So it can be manual or automated. Like I said, when you're doing all the unit testing, you probably have, within your testing or your development environment, you'll have things that'll help you determine, was it a go, no go, was it a yes or no. When we are testing, obviously you'll have a development environment, a testing environment. you're not going to hopefully test something for the first time out in production. You're going to want to have a simulated environment. The risk of a testing environment is it's clean, it's sterile. It does not have the real world hit it. So things that work flawlessly in a lab, wait till it hits the real world. And then the devs are scratching their head going, I don't get it. Like I had a situation, it was a weird little thing. We had a thing where the application launches, and for whatever reason, the first screen you see is actually not the focus. It comes up, but you have to click it. And I went to the dev lead, I said, this is really weird, look at this. Watch, when we first launch this, you have to click it in order to focus that window. You shouldn't have to do it. You should not have to click something to have the front window be the focus when it launches automatically. And she's going, wow, that's really weird. We never saw that. But you know why? They always ran things straight from their own testing environment. They never actually installed from the installer on fresh hardware. So the very way that they tested things was not how things would happen in the real world. And so you do have to test in a testing environment. You do need to test in a controlled production environment, and your testing environment needs to represent the production environment as much as you can. Realize it will never fully represent it, because it will never be as full of variables and as dirty an environment as a clean sort of lab pre-created environment. You'll never have those millions of records, so many of them corrupt, or you'll never have in a testing environment, or you'll never have people have installed all kinds of unexpected software and they have variable levels of patches and they've got this virus and that, whatever. You can't reproduce that, which is why then, of course, you have to have release management and you have to send out patches as things come up. So when we're doing the testing, of course, we need the entry criteria. So these requirements have to be met in order for us to start a process, to enter a process. And then the exit criteria, we need to make sure that this and this has happened so that we can treat this particular process as finished. So specify what is the entry and exit criteria for your testing and for this process. So when we're evaluating and developing a testing process, here's a nice checklist we can take a look at. Review the test plan for thoroughness. Make sure that the users are involved very early on, including with sketches and mock-ups and use cases and whatever. Review any error reports. Make sure there's precision in error reporting. How many times has someone said, we've got a problem, what's wrong? It doesn't work. And a help desk person wrote down, it doesn't work. Well, now we got to call the guy back and say, okay, what do you mean it doesn't work? So we need to make sure that we have enough true error reporting. Do we have screenshots? Do we have actual text of the error messages? What were the actual conditions? Who was doing it? So we need all that information so that we can reproduce the problem. Interview the users of the system. Make sure they're aware of these new additions, that they have the training, they know how to operate it, they know the procedures. If the software is purchased, acquired, rather than developed in-house, you need to test that thoroughly, and we need to test any changes. We need to make sure that we have version control also. It's so easy for someone to have version 1.1 and 1.11. So you've got, even in internally built stuff. Make sure the vendor was not allowed to replace anything behind your back or replace the testing or do their own testing as opposed to the testing you specified. If this requires some kind of external accreditation or certification, be ready for the process. And of course, have a report for management to describe whether or not this system actually met our business requirements. We have the appropriate controls and we're ready to migrate it out to the system.